Okay, so this video is on the greatest common factor. So typically this is between a couple of numbers. So we say the greatest common factor is the largest factor that is common to A and B. We write GCF AB. Okay, so let's just look at some examples. That's the easiest way to understand this. So let's try to find the greatest common factor to both of these. So just the sort of standard thing is maybe if we write down all of the factors, we can figure out any of the common ones and then find the biggest one. So 24. So one thing about this is that, again, we can write these as nice pairs. And it's really nice to kind of write them stacked because you'll see that we get them. So you always get 1 and 24. That's true for every number. All right, we know 2, we can see 2 is a factor of that. Its opposite is 12, or its other factor. 3 goes into 24 8 times. 4 goes 6 times. And the only number between those is 5, which doesn't go in there. We do the same thing with 60. So 1 and 60. We have 2 and 30. 3 goes in 20 times. 4 goes in 15 times. 5 goes in 12 times. 6 goes in 10 times. Holy smokes, everything. 7 is not a factor of 60, nor is 8, nor is 9. So those are all the factors of both. Okay, and we just look, and right, the answer for this is 12. Let's do another one, GCF of 180 and 144. So 180, we're going to do it this way again. 1 and 180, 2 and 90, 3 and 60. 4 goes in 45 times. One way to see this is, since 180 is 2 times 90, I can also sort of transfer a 2 from that to that, like that. 5 goes in 36 times. 6 goes in 30 times. Okay, 7 doesn't go. I don't believe 8 goes. Nope, 8 doesn't go. 9 goes. And 20. 10 goes with 18. 11 doesn't go. 12 goes, I believe, 15 times. And 13 and 14 both don't go. Okay, let's look at 144. 1 and 144, 2 and 72, 3. And 48, 4 and 36. If any of these, so I'm doing some checking on divisibility tests here mentally, and then trying to figure the other ones out. If you can't find the other factor, you can always do long division. 5 doesn't go. 6 goes. It must be 24 times. I'm sort of transferring a 2 that way. 7 doesn't go. 8 goes. I transfer 2 from there to there is 18. 9 and 16. 10 doesn't go, 11 doesn't go, and then 12 is the last factor because 12 squared is 144. Okay, so we just scan. I usually take the bigger number and just look, keep going. 90 isn't in there, 60 is not in there, 45 is not in there. Looks like it's 36. Okay. Now this is a bit of a pain if you look at this. So using prime factorization. So I'm going to do this example again, but using prime factorization. So first of all, I've got that, and I'm going to write 144 is 1, 2, 3, 4 twos, 2 to the 4th, 3 twos, so 3 squared. One 18, 10, 2 and 5, let's say 2 and 9, 3 and 3. So 2 squared, 3 squared, and 5. Okay. So the GCF of these are just the common terms to everything. So there's a 2 common to both. There's a 2 squared in each one, but there's not a 2 cubed. Right. There's a 3 squared in both, so we've got that. And there's a 5 here, but there's no 5 there. So I get 4 times 9 is 36. Right. So that's a little bit easier in that we've got, you know, you do have to build up the prime factorization of things, so this can be a little tricky. But once you've got that, this is a little bit easier to do, I think, than writing down all of the factors, right? It's really not necessary to write all the factors down, right? You're only looking for the biggest one. Okay. So I've got one other example. We're going to do this a little different way too. So GCF, because we'll see that this can be a little bit of a pain. 3, 3, 1, 5, and 135. Okay. So 3, 3, 1, 5. All right. I'm going to prime factor this one out. So one thing that I might note is there is definitely it's a multiple of 5. There's also a multiple of 15, or 3, right? So 3 plus 3, and then 6 is 12. So that's a multiple of 3, right? So I know 15 is one of those. Let's look at what the rest of that is. 221. Okay. All right. I'm actually gonna, let's see. 221. Okay. So I'm doing this off the top of my head. I forgot to look at what this one was. So. That's right. Okay, I sort of just looked. I'm going to skip this step. But it's 13 times 17. Right. And this, you'd have to do a little bit of work to get that. But we've got that. But what you're seeing here is part of the point of why I'm going to do something different. Here, let's see. We have definitely a 5, 135, 235, 7, 35, 0, 27, which is 9 and 3, which is 3 and 3. Okay. So, let's see, what is it I want to do? So 3315 is 3 times 5 times 13 times 17. 135 is 3 cubed times 5. So the GCF is there's a 3 common to both, but there's just 1. There's a 5 common to both, and that's it. So it's 15. Okay. So this is basically, again, a way to do this. This was tricky because you've got to do stuff like that if you're going to do the prime factorization. Okay, so we're going to learn in the next video I wouldn't say a nicer way to do it, but an alternative way to do this for some of these that get, as the numbers get a little bit larger, because they can get to be a bit of a bear to factor sometimes.